Okay, we will take a problem number 9. Okay. This is a bridge truss. Basically, this is the bridge deck and this is an assembly to make it rigid. It supports at different points here. Let us say due to the vehicle movement here, there are some forces created. Okay. We need to find out only these forces, let us say. Okay. Cj, let me just identify them with different colors so that it is easy. Cj, di, hi, which is this, and ij, which is this. We need to find out the forces only on these. Okay, this is j. Naturally, the method of sections is the best way to go about. What is necessary to do? We need to be able to cut in order to expose and look at the unknowns, right. So, if I take, let us say for example, Cj and Ij and look for cutting appropriately, the cut could be something like this and remove this part. Okay. Of course, I have to remove the reactions also, right, which means that it is necessary for me to first find out the reactions. Okay. That is not very difficult given all these forces. There are two reactions over here, there is one reaction over here, there is no horizontal force, which means the horizontal force reaction at A is automatically equal to 0. The vertical reactions only have to be found out. If I take moment about A, I will be able to find out for this. If I take moment about this, I will be able to find out at A. Okay. So, I am just going to substitute this to be, let us say Ay, and it is a known value now. Okay. I have already computed using the equilibrium of this structure. Okay. So, if I take this free body, it is now clear that member BC, Cj and Ij are cut. How many equations can I generate using this? 3 equations. 3 equations, 3 unknowns, it is possible for me to solve. Let us just do that before proceeding further. So, I am just going to redraw this whole thing for this section. This is the cut. Okay. This is the cut. This is B. This is C. This is J. This is I. That is all I need to draw. So, I am exposing BC over here, Cj and Ij. Okay. There is a force Ay acting on this, there is this 10 kilonewton acting at this point, 20 kilonewton here. All the other forces are external to this body. Okay. Now, what is needed are the member force at Ij and member force Cj. Okay. How will I go about doing this? Very simple. I do not need to find out this, which means I should try and write down the equation of equilibrium that involves moment equilibrium along this line BC. Very simple. If I take intersection of BC and Ij, which is this point, and take moment about that, the only one that is unknown here is Cj, right. So, if I take sigma m A equal to 0, that will involve this 10 kilonewton, 20 kilonewton external forces. BC will not be involved, Ij will not be involved because they are along that line concurrent to this point A. So, only Cj will be involved. So, which means it is possible for me to find out Cj from that equation. Okay. Having found that out, how do I find out Ij? Well, I have to take an intersection of BC and Cj, which is nothing but this point C, and if I take moment about this point, I should be able to find out Ij directly, which means sigma m C equal to 0. Mind you, this point is outside this rigid body, but it does not matter. I can take any point and take moment about that point and seek equilibrium, correct. In this particular case again I have these two external forces participating, as you can see, but remember this 20 kilonewton is also concurrent, which means this will not take part, Ay will take part. So, Ay 10 kilonewton, these two will take part, Bc and Cj will not take part, Ij will take part. We have already found this out, which means it is possible to find out using this. Okay. Similar is the case when I have to find out for Hi and Di. Okay. All I have to do is I have to section it, this way now. Okay. This is also a nice question. If I have to find out Hi and Di, I can section it like this. So, I am just going to erase it directly over here to draw the forces. So, I am exposing this force which is Hi, I am exposing this force which is Di, I am exposing this force which is Cd, right. Let me just circle those forces that are involved. There is this 20 kilonewton force, there is this Fy which are external. Remember we had already calculated Fy. Apart from that, there are 3 unknowns over here, which are the forces involved in this particular free body, correct. Now, I need to find out Di and Hi. How will I go about? Remember this Hi and Cd are in the horizontal direction. So, if I take vertical equilibrium, which is sigma Fy equals 0, it will not involve Cd, it will not involve Hi, it will involve only this 20 kilonewton Fy and Di component in the vertical direction, and therefore, it is possible for me to find out Di from this. Okay. Naturally, the other one is not a very difficult thing. If I take moment about D, which is the point concurrent to Cd and Di, and take moment equilibrium, it is possible for me to find out. It is possible for me to find out Hi, because that is the only unknown. 20 kilonewton will not take part, Fy will take part, Hi will take part, boom, it is possible to find out immediately.